With this kind of problem, I'd always draw on what you have and what you're trying to find out. So we're given the diagonal DB, so I can draw that on. And we're trying to find out the diagonal AC. Now, although this isn't accurate, you can probably see that those are perpendicular. And in fact, diagonals on rhombuses, they are perpendicular. The equation of a straight line, that's y equals mx plus c, where m is the gradient and c is the y-intercept. Y-intercept because when x is equal to 0, that's where it's crossing the y-axis. And when x equals to 0, that basically vanishes because you've got something times by 0. Y is equal to c at that point. And this is the gradient because you're increasing x by 1 as you do one step. And if you times that by m, that's going to tell you how much you're going up for each one of those steps. So you're going across 1 up 3, that's going to give you a gradient of 3. We have here perpendicular gradients. This gradient of dB, that's a half. So AC must be negative. A perpendicular gradient of 1 is negative 1. If I increase the gradient of 1, I'm going to decrease the gradient of the other. So it follows that if I was to halve the gradient of 1, then it's going to double the gradient of the other. But there's a simple rule we can know here, and that's that two perpendicular gradients times together is equal to minus 1. But if we have a half times by the gradient is equal to minus 1, then we want to divide by a half, or times by 2 to undo this half, and we get that it's equal to minus 2. There's a simple trick with gradients, and that's where the perpendicular gradient is the negative reciprocal. So for example, if I had 5 over 3 as a gradient, the perpendicular gradient would be minus 3 over 5, because it has to be negative and it has to be shallower than this one, or the other way around, but it has to be steeper than the other one, depending on if it's less or greater than 1 or minus 1. So now we've got the gradient, we've got m, which is minus 2. Now we just need to find c, which is the y-intercept. But we can't really know this y-intercept from this diagram. We know it's going to be quite highly positive, and it's going to be greater than 11, because it's going upwards from a. But we can't really do a scale diagram here, and we definitely haven't got time to do that. But fortunately, we're given a coordinate, and which is a. And we know that lies on the diagonal, because it's going from a to c. That means that these coordinates satisfy this equation. I'll do the algebra first, so I'm going to add 2x to get rid of this minus 2x. And we get that c is equal to y plus 2x. And now we can substitute in the coordinates, so the y value is 11, and the x value is 5. So when x is equal to 5, y is equal to 11. Crunching the numbers here, we get that 11 plus 2 lots of 5, which is 10. 11 plus 10 is 21. And that completes our equation. We get that y is equal to minus 2x plus 21. And just to check that this is reasonable, I'd look at the diagram. It's negative, it's quite steep, so that's probably true, minus 2. And it's going to cross at quite a high point on the y-axis. Higher than 11, 21. Okay, that's reasonable.